Thank you all for coming. You guys know I'm here to talk about CSS, right? Because this is really weird. This is a JavaScript group, so I'm a little weirded out right now, but it's going to be good. We're going to talk about modular CSS and decoupling the front end in a couple different ways, but primarily with modular CSS. I'm Julie Cameron. You can find me on pretty much every social network at Jewel of the Lotus. And I do have the link to the slides down there if you want to grab them now. The link will be on the last slide, too, if you don't have a chance. But let's get going. This is my cat, Ginger. Let me get my notes up. I work from home, so we like to pair program a lot. Sometimes she's more of a backseat driver, and other times she likes to navigate. But if anything, she's a really good partner because she insists on regular breaks. Notice the heated cat bed right next to the laptop. Anyway, like I said, I work from home for a pretty cool company called Articulate. We're a fully distributed e-learning software company. We do a lot of desktop software for Windows, but we're starting to port a lot of our functionality to the web in JavaScript. And we are basically always hiring. So plug for my company there. Like I said, we work remote, JavaScript. If you're into that, talk to me. I am also co-founder of the local chapter of Girl Develop It, like Brian said. Our goal is to empower and assist women who are interested in getting into technology or who have already established a career in tech but want to kind of advance it and learn more and keep growing. So we are on Meetup. If you haven't checked us out yet, definitely look us up, and hopefully we'll see you at a future meeting. I am also a big fan of SaaS and OOCSS and BEM and SMACSS and all of the other wonderful things that we're here to talk about today. So, all right, let's start off with a quick show of hands. How many of you here feel like you really just get CSS? Okay, that's not bad. How many people feel like they can write functional CSS, but they still don't really just get it? It just doesn't make sense. Okay, that's what I expected. And how many people here have no idea why I'm here, what I'm talking about, and just came for free food? Okay, I knew it. Thanks, Magnus. All right, well, hopefully we have a little bit to offer everybody and all of your different reasons for being here. So why are we here? Why are we at SEM.js talking about CSS? And I would say it's probably because CSS is kind of like this. Change one thing, the other thing messes up. It just keeps getting worse and worse and worse. Throw some importance in there. Nothing's going right at all. And you're done. So CSS is hard. The cascade is pretty delicate. And as our sites get bigger, so does the CSS. This is a partial file. This actual CSS style sheet was over 10,000 lines long. And a quote that I heard at a conference recently that I thought really kind of like summed up where we're at with this right now is from this guy, Andy Hume, in his talk, CSS for Grown-Ups. He said, "It's almost a challenge to find a development team that's working on a code base that's more than a couple years old, where the CSS isn't the most frightening and hated part of that system." I think I heard a few people say something similar to that tonight. So what are we doing wrong? What got us to this point? And the first reason I think has been around for a long time. This has been true ever since we started web designing. Before we had, plain HTML, when we started adding CSS and coming up with design comps, we have always taken this top-down approach to writing our styles. We'll get a comp from a designer, we'll start with the header, we'll work our way down that comp and implement every piece. And in the next comp we get, we do the same thing over again. So we're really not looking for ways to abstract our design into these reusable components that we'd like to have. The second issue is that we're really bad at writing selectors. don't know how to do it. And that's been true forever as well. We're only now really figuring out how the cascade can work for us instead of fighting it. So because we're misusing our selectors, we're running into specificity trouble all over the place, and tie that to the repetition and bloat, and we end up with just bad performance even, which is even worse. So once we run into this problem, we just start adding importance, and then hope everything works out for the best. Hopefully we all agree that important is the devil, and we should not use it. All right. So ultimately, though, none of this is scalable or maintainable. Like, that's the big problem here. We can't grow our CSS into these large code bases. We can't find easy ways to maintain them and make small changes or add on to them. And especially when you do get up to those like multi-thousand line CSS files, it just becomes really hard to find what you want, to organize what you want. And it kind of gets worse and worse as you keep going. So there are sort of two things at the core of this issue, and they're related. So the first one is that we're taking this top-down CSS approach that kind of follows the HTML structure, right? We're writing out our headers, we're nesting our navigation elements, we're nesting our logos, and that's what our CSS reflects as well. We can look at our CSS and know essentially what the HTML structure looks like. That's how it is now. Now, the second issue is that we're using those overly specific CSS selectors that also mirror the HTML. I kind of jumped ahead of myself there. But if you look at these two, you might start to see a pattern. It's that we've been coupling our HTML and CSS this whole time, which also probably means that we've been coupling our HTML and our CSS and our JavaScript too. And oh yeah, probably our feature specs as well. So great. That's awesome. But let me take a step back and talk a little bit about what brought me to this realization. So on one of my recent projects, I was new at the company, and the very first big task I had received was to rip out Bootstrap. So while this is a joyous occasion, it was also a rewrite of basically half the site. I had to rip Bootstrap out of the entire front end. It was everywhere, sinking its little tendrils in like it does. So I essentially came into the project with 3 months of backender generated front end code. Awesome. And it wasn't a small task to rip all this out. It took me about a month to fully extract all of the Bootstrap that was in there and port it over to custom UI and custom functionality. So it was during this process that I really started to notice like the tight coupling that we've been doing for so long on the front end. So I started with the HTML, sort of the root of UI. And all right, this is HAML, but you get the idea. Most of it wasn't too bad. I mean, HTML is pretty basic. You can't mess it up too much. All this really needed was some wrapper classes, some containers, maybe some semantic cleanup. Nothing too crazy. So this was all right. So next up, it's time to move to the CSS. And you see things like this. Admittedly, the first one was not in my project, but if you spot one of those in the wild, let me know. So if we look through these, tags, label, delete tag, we're looking for a delete tag within a label within a tags element. Okay, sure, I guess that could happen. Modal, modal body, modal toolbar. The toolbar has to be in the modal body, and the modal body has to be in the modal. Who here thinks you will ever see a modal toolbar class or a modal body class outside of a modal? Right. So why is that necessary? I don't know. UL series entries LI. All right, we're saying our series entries have to always be an unordered list. We can't ever change them, or else we're going to have to change our CSS too. This is just a pain. What if we want to put them in a definition list? Or God forbid we change it to an ordered list, because then we just broke that. So there are very specific HTML structures implied in each of these statements. They're very inflexible. They're overqualified. Like, we really don't need all of the specificity. So they kind of fight against the cascade. So of course, once I finally cleaned up all the HTML and the CSS, it's time to get to the JavaScript, or in this case, the coffee script. So we kind of have the same problem here. In our first example, we're looking for an article, we're going to mouse over it, and then we're going to look for an intro ID containing some paragraphs, containing some bold tags. Well, I hope I don't get in a semantic mood and change all of those bold tags to strong tags, because then my JavaScript breaks. All of these too, like the second example, some backbone marionette events. We're traversing the DOM here to find some links in these menus. You know, what if I get into a semantic mood and clean out those lists and replace them with something else? We've broken our functionality again. In the third example, that's actually from a Jasmine test. So add that to the list of areas that we're coupling. So of course, I wrap all of this front-end stuff up. I refactor some JavaScript and, you know, get my branch ready to push out and decide I should probably run the Ruby specs before I do that. And it turns out we've kind of got the same problem there too. So really what happened is I ripped out Bootstrap and broke the entire website. It was great. But at the root of all of these issues really is CSS selectors. They're everywhere. You know, they're in all of our JavaScript, they're in all of our tests, and they're so specific that we can't make any changes without having to fix things in another place. And this is due to that top-down approach and the selector misuse that we've been doing for so long. So we should be able to change our HTML without worrying about breaking our site. I mean, it's HTML. Really, it shouldn't be that hard to change. So there's sort of a two-part solution to this problem. And the first part is really, really easy. It's that we need to stop using CSS selectors for non-CSS stuff. Use data attributes, use IDs even, use JS prefixed classes. Just don't use anything that's going to couple presentation to functionality. You want to use something that's going to be more reusable and logical, especially in your JavaScript and your feature tests. So things like data attributes are kind of perfect for this. We could take our article mouse over and, you know, put a data hoverable on that article, and then just say, hey, if I hover over this, find anything that's highlightable. Then it doesn't matter what element it is. It doesn't matter where it is within that container. It's just going to work. So the good thing about data attributes is that we're all smart enough not to mess with them. If a front-ender goes in the code and wants to refactor the HTML or wants to reclass everything, we know better than to rip out any data attributes because they're customarily tied to functionality. They don't serve really any structural or stylistic purpose unless you write CSS that targets them, but I don't know why you would do that. So, all right, once we've cleaned up these kind of functionality selectors, we've moved over to data attributes or IDs or whatever it may be, we've sort of eliminated JavaScript and texts and all of that non-HTML and CSS stuff from our problem area. So at this point, it's time to start modularizing our CSS. And this is a little harder to do because it requires kind of a bigger shift in the way you think about CSS and design in general. So this is what we're here to figure out today. So what makes modular CSS great? Why is it the answer to our problems? And let's start by stating the obvious. It's modular. If you can build a well-functioning modular CSS system, you can actually get to a point where you get a new comp from a designer and you can implement the entire design without writing a single line of CSS. And when that happens for the first time, it's like the absolute best feeling in the world. You've completed your modular system. It works perfectly. Next reason is that modular CSS is easily understood and predictable. Our components are intended to behave the same in all contexts. Doesn't matter where you put the component, it's going to look the same, it's going to behave the same. So for that reason, it becomes easy to look at your comps and know exactly what components you'll need to piece together this page. It's easy to write the code because you've got systems in place for naming things that you don't have to go look at your CSS and try to remember what you named this thing. It's more intuitive. It's also very clean and maintainable. So adding new styles, adjusting old styles, it becomes very quick and easy to do. And the best part is they don't break anything else on the site. So scalability, it's hard to break and it's easy to add on to. If we focus a lot on reducing our selector specificity, those bad selectors that we've been writing all the time, we actually gain more flexibility, which we need to expand and to keep adding on to our site. It's reusable, it's dry. Modular CSS kind of eliminates the need for like the copy and paste duplication that we often do in our CSS. You know, you want something to look like this thing that you already have, but those two sections in your style sheet are 3,000 lines apart. You're probably just going to copy and paste that, right? And lastly, it's very, very, very organized. And with a couple best practices and new conventions in place, you know, there's kind of a place for everything and everything has its own place. So these are all really good reasons. Hopefully you agree. And fortunately, we have a couple systems to choose from already. Now, OOCSS, BEM, SMACSS, Atomic Design, those are the ones that we're going to look at today. But there are seriously, like, probably 1.5 million different architectures because everyone's doing their own thing. So let's start off with sort of like the root of all of these systems, OOCSS, which stands for Object-Oriented Cascading Style Sheets. So what is OOCSS? OOCSS is a scalable, maintainable, semantic, and predictable approach to writing CSS. It is a technique, not a technology. Its principles and guidelines, really how you actually implement it is kind of up to you. So let's look at where OOCSS kind of came from. OOCSS was created by this chick, Nicole Sullivan, while she was doing a contract job at Facebook. They had essentially hired her to look at all of their CSS, look at all of their markup, and fix it because they had these exact same problems. They had a 10,000 line style sheet. They were incapable of scaling at that point, so they called her in. And what she did is she just sat down and like read the styles, top to bottom, looked at all the markup, and was looking for these patterns. And the one very repetitive pattern that she found was for this module that she then created called a media object, which she said could save hundreds of lines of code. So what's a media object? As defined in her OOCSS wiki, it is a content block containing a fixed size media element, like an image or a video, along with other variable size content, like text. So, okay, that definition's kind of abstract, but we know she was working at Facebook. So what does that sound like that we might see on Facebook? Facebook status. So this image on the right here is a admittedly pretty old version of their Facebook status line, but everything highlighted in red could be marked up and styled with this media object. That's like 95% of the page. So she literally did eliminate hundreds, maybe even thousands of lines of code just by coming up with this one reusable object. So if we look at this media object in code, it's pretty simple. We've got a media container. It's going to have a media image in there and then a body area. And in this case, we've got a title. So while the contents of the body could change, we could put anything we wanted in that media body. And while even the size of the image could change, there are common base styles that are in this that kind of eliminate the need for this repetition that we would have otherwise implemented in our CSS. So think about how this object might change the way we write styles and compose markup. So let's dig into these objects a bit more. What is an object? In terms of CSS and kind of really any object-oriented system, it's the abstraction of repetition into reusable objects. So this is all about learning to think in terms of reusable components rather than in selectors. don't think about the HTML tree anymore. Don't think about what type of element we're using. Only think about the object as a whole and what kind of pieces it needs to have. So these objects are generally made up of a few parts. The first is the HTML, which could be one or any number of nodes of the DOM. In the media object, we saw there was a wrapper element, an image within there, a body within that. It's the CSS declarations that style that HTML. We might have components like background images or sprites required for the display. This one is a little less important. And then we've also got JavaScript that adjusts the behaviors, has some listeners or methods associated with the object. This is the functional side of the object. So if we put all this together, we're essentially talking about modules with variations. And on one side, oops, my bad. On one side, we've got pure CSS variations. We've got kind of different looking buttons. Maybe we have a primary button and a warning button or a call to action button that are all generally buttons, but they look different. And then we also have variations through pseudo-classes, like hover states, media queries, that sort of thing. On the other side, we've got variations via JavaScript. So these are classes that we might toggle on the object that then alter the appearance via CSS. But all of this is CSS based. So let's look at this module concept from a CSS standpoint. At the top, you've got the object. And you might hear this referred to as modules or components. Everybody kind of mixes and matches them all the time. So I've already said module a bunch of times. I'll probably say it again, but I mean object. In the case of our media object, that would be the media class. Next up, you've got child objects. And these identify the relationships within the object as a whole. So with our media object, we had a nested media image and a media body. Now notice I'm not identifying what the actual HTML element is at all, because it doesn't matter. If I put that media body class on a div or a paragraph or a span or whatever, it should look the same every single time. Now the third piece is modifiers, and these are like CSS design variations. So things like media inline. Maybe we want our media object to, instead of display block and take up the full width, we want it to sit in line with a bunch of other media objects. So I could maybe just apply a media inline class to my media object to have that modification. The same thing goes with child objects. You could just as easily say, well, I want my media image to be on the right side instead of the left side. Those are just design variations of the same object. And lastly, we've got states. And these could be both CSS or JavaScript adjustments. Things like your pseudo styles for hover or active states. Things like JavaScript adjustments. Maybe you've got a collapsed state on your media object. Maybe you've got an active state on your media object. All right, so I think we're probably starting to sort of get this object thing now. But before we can really get into the code, there's a few best practices that we should at least consider. So first of all, there's this principle of single responsibility. Most modular systems embody this principle really, really well. Do one thing, do it well. Our object classes typically have one responsibility. And there are various kind of sizes of this responsibility. We might have an object that is super simple, maybe only changes one style property, but we might have bigger objects that handle a little bit more. But generally, the responsibility of the object should be entirely encapsulated by that object, by that class even. And when we say it should be encapsulated, what we really mean is that the object should be flexible enough to stand on its own. It shouldn't matter what context or container it's in. It should work the same everywhere. So next up, we need to form a very strong dedication to classes. Use classes for the object itself. Use classes for the child object, for the modifier classes, for the states. Just class all the things. And the reason for that is that IDs are super specific, and they're really hard to overwrite, and they just botch up our specificity. So if we use classes, we can kind of mix and match these objects together in a way that gives us a lot more flexibility than we would have otherwise had. Next up, we've got naming conventions. And of course, there's a lot of ways that we can do this, but you really just want to pick a system and be consistent. Like it does not matter what you do. Whatever you choose, make sure that the whole team understands it and is in agreement and is willing to use it. So like I said, there's a lot of different ways we could go. There's a couple examples. Maybe you've just got a flat naming system. Maybe you want to go camel case or dash or underscore or BEM style, which we'll talk about a little bit more in a second. But using any pattern at all will make your styles easier to navigate. It'll make it easier to identify what is an object, what is a child object, what is a modifier, what is a state. And these are some different formats. But like I said, you also have to think about how you're going to identify your children and your states and modifiers. You know, will you lowercase your object and then make your child like a camel case thing? Will you separate it by a dash, or will you separate it by an underscore? These are helpful decisions to make, because once you have the consistency, it makes reading the code and parsing it and understanding it very, very quickly super easy to do. So we saw in the last slide a mention of BEM. Let's take a deeper look at that, because we're going to be using that in our demos. So BEM stands for Block Element Modifier. And it's an entire methodology developed by Yandex, but a lot of people really kind of solely just use it for their class naming conventions, which look like what you see here. So let's break this down a little bit more. First up, you've got your object. This is the block in BEM. It's your top level thing. Next up, you've got a format to identify your child object. This is the element piece of BEM. In this case, they use a double underscore. And next up, you've got a format to identify your modifications. In this case, it's a double dash. Now, you could also use that double dash indicator on your child element as well. So block element modifier. It's obviously a little funky looking. It definitely takes some getting used to. It kind of takes up a lot of space, but once you get used to looking at double dashes and double underscores, it becomes really easy to very quickly see the relationship between the objects. I can now look at object underscore underscore child, and without knowing what the words are, know that that's a child class. So it's very, very organized. Now, the next thing we need to consider is semantic versus presentational naming. And this is maybe less of a best practice and more of like an ongoing debate among front-end developers. So let's talk about what each of these mean. So presentational naming, these are class names that literally describe how the object looks. So grid call 9, button small, float left. These are all basically style properties kind of written out as classes. And sometimes these are referred to as utility classes. You'll see that in a few places. But very often, they're literally single responsibility. They might adjust a single CSS property, especially if you look at like float left. Like I would bet money that there's only one property that's going to adjust. Now, this is also one of the cases where using important flags is maybe acceptable. You know, if I've got a float left class, chances are if I apply that to an element, like I definitely want it to float left. I don't care about any other styles associated with that module. I definitely want it to float left. For that reason, you can kind of get away with using important selectors here. Now the next type, semantic naming, sort of describes what the object is and almost literally what the content of the object is. So things like bookmark, article, call to action. Now you might start to guess, and if you look at this example down here, you'll see there's only one class there, where with our presentational naming, we've got 3 classes that do the same thing. So with semantic naming, you're going to use far less classes than you would with presentational and reduce what we front-enders like to call classitis. but that might not be the way you want to go. And we'll talk a little bit more about classitis later on. So for most people, making a decision one way or another is probably going to come down to the question of what would you rather have, dry HTML or dry CSS. If you want dry HTML, go semantic. You're going to use far fewer classes. If you want dry CSS, which is going to be much, well, they're both flexible, but in a different way, flexible in your CSS rather than flexible in your HTML. So it's kind of a question of which is easier for you to maintain, what does your team want to do. You know, you've got to get kind of a consensus for that. Another factor to this is, do you even have access to the markup? Are you maybe styling content coming out of a CMS system where you don't have access to adding classes to the container elements or whatever the CMS is spitting out? So there are different things to consider that you might go one way or the other for. So as I said before, it's a highly debated topic. You should definitely look it up online and read all about it. We'll talk a little bit about it more later on. A lot of people ultimately, and what I do, is to use kind of a hybrid system, a mix of both. So I like to use semantic naming for my module classes and then presentational naming for my utility classes. So this example down here, I've got a media body object, which is a kind of a semantic name, and then copy small and content secondary. So it's always going to look like my media body, which has a defined set of styles, but in this case, you know, I want the copy to be a little smaller, and I want the content color to be a little different. So that's my preference. But ultimately, if there's a single thing that you should know about these best practices and about modular CSS in general, it's that seriously no one knows what they're doing. No one knows at all. These concepts are still like fairly new in CSS. Like we've really only started diving into them in the last 2 or 3 years, which is like a long time, but in dev land it's not. So no one really knows. No one has formed any consensus that one way is the best way. We're all just kind of experimenting, and every single project that you end up doing is going to be kind of different. So with that, let's move on to OOCSS. What we all just talked about was kind of the more general concepts of modular CSS, but OOCSS has these kind of 2 specific principles that define how you build out these systems. So the first one is the separation of structure from skin. And let's just dive right into that. All right, so structure is defined as repeating invisible patterns as reusable structures. So this is essentially asking what makes these buttons look like buttons. That's the structure. Now, skins then are defined as repeating visual patterns as reusable skins. So what makes these buttons look different from each other? How are they skinned differently? So let's look at this button structure a little bit more. Shout some stuff out. What makes these buttons look like buttons? Rounded corners. Padding. What's that? Border. Yeah. All very good stuff. So that is obviously not an exhaustive list, but you can kind of see all of these things are applicable to every single one of those buttons. So if we try to pick out what's different about these buttons, what makes them look different, what are these skins? Color. Basically background color. And maybe a font color in one case. So when we put these structure classes and these skin classes together, we should be able to style like just about any single element to make it look like a button. In this case, we've got an anchor, a span, a button, a submit input, a label. By applying the button structure class and the button skin class, we can make all of those different things look like buttons. So this is sort of single responsibility in action. Our button class, the BTN class, handles purely the structure. And then our skin classes handle purely the skin, the cosmetics. They do one thing. They're interchangeable. We could put any skin class on any of those elements, and it's going to do what we want it to do. All right, so we're going to do a code demo that will show you kind of how to do this. Does anyone have any questions before I get into that? All right.
I had a question.
Sure.
With this in mind, when would you recommend using IDs?
When to use IDs?
Yeah.
Wait about 30 minutes.
Okay.
All right, so let me pull these screens up. Oops. All right, so we have this image here of what we want our buttons to look like, and our goal for this is to make actual styled buttons. So let me move this up here too so I can go through the slides. So our first step is to get the structure set up. We want all of our buttons to look roughly the same without any skins. They should all be buttons. So if we start with that, I should look at my laptop. Does anyone know how to mirror? There we go. Okay, that's much easier. All right, so we're going to start with these basic elements. Nothing fancy. They don't have anything going on. They don't go anywhere. They're just default elements. And we're going to take our code and make them look like those buttons. So we've got some plain old HTML here, just a button, input, anchor, span label. And probably the first thing that we want to do is give them all a structure class. We'll start there. And we'll call it button. So now that we have that, and I'll make that wrap there so we can see it, we can start writing some styles. So we'll define our button selector there. And let's just start by saying, I don't know, border none, background. We'll just make them all the same. The colors should be all the same. What's that? Oh, we're good though? Okay. We should have a 2-pixel solid border. We'll leave that. Let's do height 42 pixels. I'll do a line height of 38 pixels. You can see those happening now. You'll start to see like these elements look different, right? We're adding the same styles to them, but they've got sort of defaults that we want to eliminate at this point. So right away, like our anchor, we have a text decoration. We don't want that. So let's get rid of that. Now our buttons and inputs have some default padding, it looks like. So let's just reset all of our padding to 0 and 0.75 EM. All right, that's looking a little better. Let's just clear out margin just because we'll display inline block. And how about WebKit appearance none? That should help. All right, we're looking a little bit better now. Let's go font size 12 pixels. So what we're doing here is like we're just eliminating the variations between all of these different elements. And I'm not going to remember all of these right now, so I have a nice backup that we'll just copy and paste. I can never get that hotkey right. All right. Oh, and one important thing that you should always check for is pseudostates. So hover, we're looking good on, but what if we actually click them? We've got some outlines on our buttons and inputs. So we want to eliminate those as well. outline, none. All right. So now all of our buttons are exactly the same. They have no hover state, no focus state. This is our structure. So now if we want to go to the next step, which will be to start adding on those skins. So let's go back to our code here, and we'll switch out our image so we can have something to work against. All right, so we kind of need like a primary, a secondary, and a tertiary button style. So let's duplicate our role here a couple times, and then we'll start adding those classes. And just like we imagine, button primary. We'll do button secondary on this one. Secondary. And then we'll do button tertiary on this guy. So we've got 3 sets of buttons now. Now, if we look at our finished product here, there's really only 3 properties that might vary for any of these instances. Anyone know what they are? You're all so smart. All right, so let's make some selectors. All right, so let's see, button primary. We want like this green font color and this green border. So let's do DA55, badass. And that will also change our border color, but let's just be specific, because if we were doing this in a tool with a preprocessor like Sass, we might have all these color values within variables somewhere. So let's put these in here just to be specific. So we'll do a background of white and a border color of badass again. All right, so now our primary buttons are looking pretty good. If we want to do our secondary buttons, it looks like we've got a color. It's maybe around 666. The devil's cool. We'll have a white background and a border color CCC, sure. Looks pretty good. And then our tertiary buttons. Now these ones, you might think we only need to change 2 properties for. They don't have a border at all, so maybe we would pull the border off. But what if we just made the border the same color as the background? Then we don't have to say, okay, for this particular button, let's make it 4 pixels taller, or let's add these extra styles to like compensate for our missing border. It's just a border that's there that's the same color. So we'll set our color to be, we'll go with 666 again, and a background of DDD, and a border color of DDD. All right, so we've got some borders now, or some buttons. No hover state still, but they look roughly like our desired buttons. So let me just copy the exact color values, and we'll throw those in there instead. All right, now our buttons look exact. So on to step 3. We've got some states to deal with. In this case, this darker version of the button, that's going to be our hover state. So we want to set up some hover states now. Now again, this is going to be really only adjusting 3 properties for each element. We're going to switch up the font color, the background color, maybe the border color too. So let's start with our primary button. Do button, primary, hover. And we're going to kind of reverse the colors. So we want our font color to be white, and we'll have our background color as 9A, B, whatever, and our border color as 9AB, whatever. Get rid of that. We don't need that. So now we should have some nice hover states on our primary button. And we can do that again for the secondary button. And in this case, we want a white color again, and then a dark gray background and border. So we'll do that. background should be 666 and border color 666. And there's our nice tertiary hover state. And again, we do that for, or secondary hover state. We do that again for tertiary now. And in this case, we want a darker gray background and a white label. So color, FFF, background, CCC, border color, CCC. And now we've got some hover states for our tertiary buttons as well. So all right, what's next? Now we've got some modifiers to address. So we have these sort of medium-sized buttons. We've got these kind of small buttons, and then these are, you could say, like block buttons. They take up the full width of the space. So if we want to get into those, and let me just copy my colors over so we have those the same. Oops. All right. So we're going to need to make a few more elements here. Let's do medium, small, and one more for block. And then we'll do essentially, well, okay, let me make it look exactly like the picture. Hang on a second. We are on this one. We want it to look like that. So we'll copy one of these. And I put them all in different colors in each row just so we could see that they really are the same. They align the same. They're working perfectly. So let's just do that too. All right, and then we'll do 3 of those. So our first one we want to be button medium. It's a fine name. Second one we'll do button small. And then the last one we'll do button block. So we've got all of our elements here. They're looking pretty good. If we want to style our button mediums then, we'll say maybe a little less padding. That's probably about it. And some height differences. So our padding, we're going to go down to about 5 EM. And then our height will go to 36. And line height, 32 pixels. Mostly good. We'll fix that later, but you get the idea. Button small then, we'll do basically the same thing too, except I think in this case we want a slightly smaller font as well. So in this case we'll say padding 0.5 EM. We'll turn that to, well, we'll go with 1. And then we want a shorter height and a shorter line height. All right, close enough. Now, if you're wondering about the height and line height thing, why they're not the same number, why line height is 4 pixels less than height, it's because we're compensating for 4 pixels worth of border. We've got 2 pixels of border on the top, 2 pixels of border on the bottom. Having that line height subtract that value is going to make sure that it's centered within the button. So, little tip there. All right, so we've got roughly our medium and small styles now. Let's add a button block, which you guessed it first is display block. But this actually isn't going to do everything we want because buttons and inputs are special. I don't know why, but you have to specify with 100% for them. Kind of defeats the purpose of display block, but whatever. And we'll go ahead and give them a vertical margin as well. All right, so now we are looking pretty close to what we initially wanted. We could even go one step further and create sort of an inverse style for these hover states. Maybe we want buttons to kind of inverse their colors and look normally dark green and on hover look white. So this is actually pretty easy to do. now that we've got all these things set up. But we could add an inverse class to a few of these elements. All right, no change yet. So we want our inverse button primary to look like the hover of button primary. So this is really as easy as saying button primary dot inverse look like the hover state. Now, if we hover over this right now, nothing's going to happen because the button primary hover state looks exactly like the button primary inverse hover state. So what we can do is apply our inverse hover state to our normal button style. I know we've got inverse buttons. And we could do that with the other three as well. Hopefully that kind of makes sense what's happening there. Does anyone have any questions about any of this? Yeah.
So if you were to put a CSS transform, say you wanted to do a parallel slanted button, would you put that, where would you put that? Would you put it in, where?
Sure. I think it would depend on how you wanted the transform to work. Like, is the transform going to be on every button in the entire site? Or do you have maybe like a call to action button that on hover you want to move around or grow or do something like that? If that were the case, it was only like this one specific type of button, then I would make a modifier class for that, like button expandable or something like that, that you would then just throw that class on the element. Yeah. Yes?
Would your inverse normally be button?
That's kind of one of those like fuzzy areas. Inverse is one of those things that like just the word inverse can apply to a whole number of different things on the site. So it's kind of like a weird utility class. I don't really have a good reason for using one or the other. It's shorter in this case. I don't know. Like I said, no one knows what they're doing. Yes? Ideally, you should probably stick to one system or have at least any system at all. I've heard some people like to use rem units for like the module as a whole, but then m units within the module, and then you'll use like pixels for your base reset. There are a whole bunch of different ways to do that. This is a bad example. All right, let's keep going then. So that was the button demo. And that's going to bring us to the next section, container versus content. Let me see if I can get this to display right without mirroring. Oops. All right. So container versus content. This is the second principle. And it basically says that objects should look the same no matter where you put them. And another way of saying this is that you want to avoid location-dependent styles. And these are the types of things that lead us to that duplication. So let's look at an example. So let's say we've got this category list, just a listing of categories. Maybe it's in a sidebar or something, and it's got a header. The header just says categories or something like that. What if we wanted to sort of get these exact same styles on an H2 in the footer? What would we do? What if we had a 5,000 line CSS file and we wanted these header styles on a footer header? We'd probably just copy and paste them, which is fine if you're dealing with a 5,000 line file. But then, you know, what happens if 3 months later we want these exact same styles on an H3 somewhere else? We're probably going to just keep copying these styles. So this is kind of a bad thing to keep doing. All of our heading styles, the H2s and the H3s, are all tied to their container elements in this case, the category and the footer and the sidebar. So they're not reusable. We can't take those styles and apply them anywhere else without just copying them. So what would be a better way of doing this? Well, we could group our selectors together. But like I said, if we're working in a 5,000 line CSS file, that's going to cause us issues. We're not going to know where to look when we actually want to change these styles. You know, do we go to the category list, or do we go to the sidebar, or is it in the footer? Where are these things at? So it's kind of impractical to do that in this case as well. So what OOCSS would have us do, let me take a step back then. So if we look at these, our containers are the classes, the things that the headers are within, which would make our content the H2. So OOCSS then would say, well, let's abstract those H2 styles and put them in their own object. And this is a class object that we can reuse anywhere we want those styles ever. So in this case, we would create maybe like a section header style that we could apply then to our sidebar H2, to our footer H2, to our other sidebar H3, and all of them now will look like a section header. Now this serves us two things. One, that anything with a class of section header is going to look like a section header, and two, that all of our H2s and H3s will look like normal H2s and H3s unless we put this class on them. So it's kind of a two-sided benefit here. So here's sort of a quote that I think sums up what we're trying to do here. And it says that with OOCSS, we're encouraged to give more forethought to what is common among different elements and then separate those common features into modules or objects that can be reused anywhere. So what this really means is that our section header is an object, our button is an object. These reusable pieces that we can just plug and play and put together are all objects in object-oriented CSS. So we're continually abstracting these styles. Both of these, you know, they're single responsibility styles. They do one thing. They make an element look like a section header, or they make an element look like a button. They're entirely encapsulated. They will behave this way anywhere that we put them. So let's take a step back and look at how we might start building one of these modular systems, kind of from scratch. And the first thing you would want to do is start with your base style. Start with your default elements, your CSS resets, how you generally want things to look like always. From there, you would probably start building out sort of like your building block objects, things like lists, navs, button, media, objects. Very, very simple things that are going to be very reusable and plug and play. And then the third piece would be to move on to these larger composite objects, things like headers and footers, that pull in all of these smaller building blocks, maybe even some of these base elements into one whole component. So what does this actually look like in code? So in this shot, we have a share navigation section, bookmark share drop-down menu with some options. And then we've got some code on the right here. And this is HAML. If you've not seen HAML before, the orange stuff is the element, the type of element, and all of the blue stuff are chained classes. So if we look through this code, and if you just focus on the blue stuff, and maybe keep BEM syntax in mind, you'll see a lot of repetition. We've got list hors right, list block all, media inline, media image, icon bookmark, media, drop-down, media, media, icon, media, drop-down, list, media, media, icon, media. And it goes on and on and on. But really the point is that we're using 4 different objects here. We've got a list object, a media object, which is probably the core of this whole setup, a drop-down object, and an icon object. These are all standalone pieces that we have mixed and matched to create this whole share component, this bigger piece. So, all right, we're going to do this in code now at a much simpler scale. We are going to take, oops, where's my thing? We're going to take a sidebar and turn it into a reusable component. Let me mirror my display again. All right. So let's get rid of that and that. This is what we want to end up with. A left sidebar, a right sidebar that's right aligned, and kind of a footer section that looks exactly the same but is full width. So we're going to start with just this left sidebar. And if we open up our index file, open up our style sheet. So in our index file, we've basically got this aside, this left sidebar, and we're going to uncomment this footer so we can start working on that. So the footer right now is kind of just sitting there right next to the sidebar, has some couple weird styles. But the first thing that we want to do is sort of abstract the styles that are the same. So let's start by looking at what we have for styles right now. We've got an aside with some H2s and list styles tied to it, some H4 styles, paragraph styles, but everything's just tied to that aside element right now. That we kind of want to change. So let's go ahead and make an assumption that all of our heading styles, the H2s and the H4s and the paragraphs, are kind of base default styles. They're going to look the same everywhere. So we'll pull those out. We'll pull out our paragraph styles. And I'm just moving them up to the top so they're kind of outside of our module area. And then we'll pull our H4 out as well. So all right, we're already looking a little bit better. So now that we've got that, we want to make this a footer. So what do we need to do that? Well, let's create, how about a footer class? That makes sense. And right now our float, our sidebar is set to float left, which is why our footer is setting next to it. Really, we pretty much probably always want our footer to display block and fit the whole width of the page. So let's go ahead and just clear both. We'll just clear the floats. Oh, I also have to apply the class to the footer element. All right, so that's a little better. Now, instead of just calling this aside and styling the element, let's stick with what we want to do and use a class here. So we'll just call this sidebar. Doesn't matter if we specify left or right. And then we'll change that to sidebar. So we'll put some spacing up here too. All right, so next up, we've got all of these list styles and these H4 styles. These are what we wanted to abstract next. So let's start with this aside UL piece. We're saying we don't want any margin, we don't want any paddings, and we don't want any list styles. So I'm going to go ahead and say, okay, this kind of sounds like a bare list. We're taking off the things that make it look like a list. So let's create a list bare class, and then we'll just go ahead and apply that to that UL element. And we'll do that for both sections. All right, so no more margin, no padding, no list style. Next up, we've got this aside UL li bit. And right here, we're saying have some vertical margins, have a bottom padding, and have a border on the bottom. All right, so we're applying these to every list item in this UL object. So what if we made this kind of a modification of the list? What if we said that it's going to be like list underlined, right? So now what we can do, well, in this particular case, we'll have to specify li. I think that's how I intended to do that. But now our footer section has these nice underlined list items. All right, so what's next? We've got these link styles that only exist within H4s. Now in this case, maybe we'll just consider that this extra H4 specificity is a little more than we need. You know, we don't necessarily care if they're always in an H4 or if they're in an H2, but what we want them to do is look like this. We want them to be kind of content colored and have this blue hover state instead. So why don't we call these like link primary? And I'm going to call them link primary because our primary content color on the site right now is black, and we want our links to essentially look like the primary content color. You could name these any number of ways, but this is what I'm going to do. So you replace your aside h4 anchor selector with link primary, and then we just go over to all of our anchors and add a link primary. So you could see the unclassed links don't look like they should right now, but that is easy enough. All right, so there we go. We've abstracted all of these sidebar contained styles into these reusable classes now that we can use in a sidebar, in a footer section, really anywhere we want to use them. So the third piece of this is that we also want this right sidebar. We want it to float to the right and also have aligned content on the right. So we can do that. Let's copy our first sidebar, and we'll call it our right sidebar. And as you can see, they sit up right next to each other right now. So as a whole, we want our sidebars to look the same. We just want them to go to different sides of the screen. So let's look at our sidebar class right now. It's float left. I think right now we want to abstract that style, right? We don't want our right sidebar to float left. What we could do now, though, is create a float left presentational or utility class that has one responsibility, and that is to float left. We could do the same thing for float right. And now on our sidebar objects, float left, float right. There we go. Not too bad. And then lastly, we just want to right align all this copy. Probably pretty easy to do. What if we just made an align right class? And then just said align right, text align right. Perfect. So now we've got this kind of set of utility classes. We've got some base styles. And then we've got these sort of larger single responsibility objects. We want our sidebars to always be 15 ems wide. We want our footer to kind of clear anything that's above it and have some space above it. We've got these list modifications, a list bare, a list underlined, and then we've got some link modifications. So does everyone kind of get what's happening in the container versus the content and how we're splitting those two up? Does anyone have any questions? Yeah, you could totally do that. We could have done something. We could have left the flow left here, and then maybe have a modifier on the sidebar. We could say sidebar right, and all that has is float right. Now, the key thing to doing this then is that we have the order of our styles set in the style sheet. So we need style right to come after, or sidebar right to come after sidebar in our style sheet. Anything else?
You almost always style the base content on the variation tags.
Yeah, you kind of want to, if we know like from the beginning, like all H4s are going to look like this, all paragraphs are going to have these default styles, then yes, on the base element tags is totally fine.
I'm thinking of like a more complex site where you might be using H4s for one thing on one part of the site where they're a different thing on another part. I know that's bad.
Right, yeah, that would be totally the case for something like that section header class. Because with that, you're saying, I want all of my H4s to always look like this unless I add this class, and then it's not going to look like an H4 anymore. And then it doesn't have to be an H4. It's going to look like your section header. So, all right, let's get back to the slides. A little bit more. So that was the separation of container and content. Actually, before I get to these, now we didn't go too crazy with our classes. We abstracted a few things, we made a couple classes, but we could have actually gone a lot crazier and a lot more minuscule. And I will show you what I mean here. So this is the same thing, a left sidebar, a right sidebar, and a footer section, but with a lot more classes. We see this, can everyone see this in the back? Okay. We've got like this container left thing, a section header, an item list, no margin, item list item, separated, no margin, area heading. These are much more granular styles, and for our demo purposes, like this wasn't really necessary, but if you have a much more complex, diverse site, then you might choose to go with something like this. But this is very much a presentational single responsibility approach. That padding top large really just puts a padding on. Align right, text align right. Separated, all it does is set a border bottom. No margin just clears out the margin. So it's totally up to you to decide what level of granularity you're comfortable with. That's kind of the area of flexibility that we have in OOCSS and modular systems in general. So with that demo right there, we saw one of the concerns that people have with OOCSS. One of the things that holds people back from using OOCSS, and that's the abundance of classes, what we call classitis. And if there is one true downfall of OOCSS, this is it. It's that it bloats our HTML with all of these classes. But what's ultimately happening here is that our OOCSS, our CSS in general, is no longer reliant on our HTML, but our HTML is now reliant on our CSS, or more generally, our styles. The HTML doesn't necessarily care what the CSS is. We're just saying style it like this. So this is okay. It's an approach, after all. You don't have to use this system. It just means that you're going to have a lot of classes in your markup. So if we look at this little example here, we see the same thing, all of those classes. But it's a pretty good balance of presentational and semantic in this case. We have kind of presentational classes like padding top large and no margin, but then there are semantic classes like section heading and item content that don't tell you what it looks like, but more what the thing is. So like I said before, classitis is a really big topic of debate among front-end developers, and some of the questions that we ask and each have our own opinions on are things like, do classes even have semantic value? To whom are classes semantic to? Does it even matter? Should classes always be semantic, or should they always be presentational? Is it okay to mix them, or is it better to have one semantic class or multiple mixed classes? These are all things that people argue left and right, one way or another, that, again, there's no consensus on right now. If we were to argue the presentational side, which OOCSS would have us do, we'd point out that classes don't actually have any meaning to the browser whatsoever. No semantic meaning. They're purely there to match styles to elements. Classes do, however, have semantic meaning to developers. I can look at a class, and if it says padding top large, I know what that means, and as a front-end developer, that has value to me. Presentational classes are also reusable. They don't couple to the content. Our no margin class doesn't care what element it is. It's just going to remove the margin if there is one. And lastly, the content kind of describes itself, so why does the class have to? You know, these are all arguments or questions that people who want to use presentational classes would argue, and they're all totally valid. But again, ultimately, it boils down to sort of which types do you prefer and what are your needs. If you're building a really small, very basic site, 4 or 5 pages, maybe you're going to go with semantic because you just don't have the variation that a larger scalable site would have, which might require presentational classes. So again, which is easier for you to maintain? Which do you want to work with? What does your team want to work with? And go with that. So that was OOCSS. There's not really much more to it. Like I said, it's an approach and there are guidelines. So how you organize your code, the granularity to which you make your objects is totally up to you. Now, let's take a pretty quick look at some of the other systems that have sort of grown out of OOCSS that sort of give us additional guidelines and additional ways of organizing our objects. The first one is called SMACSS. Stands for Scalable and Modular Architecture with CSS. And SMACSS was created by this guy, Jonathan Snook, while he was working at Yahoo and Shopify. And SMACSS is all about categorization. Whereas OOCSS only really had one type of object. SMACSS splits objects into 5 types. And those types are base, layout, module, state, and theme. So let's dig into those a little bit. Oops. So SMACSS base type is basically your CSS resets, your default styles, those base element selectors that we just saw in that demo. You know, body, HTML, anchors, heading elements. These are typically single responsibility selectors, maybe pseudo selectors that you style along with those, but your bare bones styles, what things should generally look like on the site. Now, the next type is the layout. So this is going to define page sections and things like grids, things that hold your other pieces together. So Snook splits layout components into major and minor styles. Major styles he identifies as things like wrappers or headers, things that are single-use components. They're only ever going to be on the page once. And he actually encourages the use of IDs for these element styles because they are one-time use. You're probably not going to run into too many specificity issues with that. Now, the minor components, like we've got down here, are things like grid classes, things that you might have more than one of on any given page. Those he suggests using classes for as usual. So the IDs on major layout components are his one exception for using IDs. Now, the third type is the module. These are sort of the reusable parts, very similar to like any given object in OOCSS. They're the discrete components of the page. They sit inside layout components. They're designed to stand alone. They use classes for their object names. And he recommends avoiding element child selectors. We can see in the top example here, our nav item, we've nested an anchor selector in there. Now, he says, try to avoid these in general unless you are absolutely sure that that element will be there all the time and that it's also within one level of the class selector it's contained within. So in this case, we've got a nav object. It's got some items, which maybe would be list items. And then we've got an anchor within that. Chances are, if it's a nav object, it's going to have links because that is the definition of a nav object. It is something that contains a set of links. So we can reasonably assume that there might be an anchor within a nav item. So that's kind of acceptable to Jonathan Snook. Snook also calls his modifiers subclasses. So where we see in this bottom thumb example, we've got a thumb dash dash featured, whereas in OOCSS, or generally you might hear those referred to as modifiers, he will refer to them as subclasses. Now, the next piece is state. And state applies to generally modules or layout objects. They're different from module subclasses because they indicate that there is a JavaScript dependency. So these classes that we've got here as an example, is hidden, is visible, is collapsed, is active. Those are all things that we might toggle on and off an object through JavaScript. However, sometimes we want a very specific style applied to an element for that state. Maybe we've got an is collapsed state that generally shrinks something down, but for this one component, maybe a widget or something, when it collapses, we want it to do something slightly different. So he allows for module-specific rules, where we say include a module name and make sure the style resides with the whole module. So we've got a tab here. We're going to define all of our tab styles, and then we're going to tie any specific states for that tab right there with it, and we're going to kind of namespace it is tab active. Pseudo states and media query states would also be included here. So you're going to tie those all to the module. The next piece is theme. Most sites don't need this. He states that in his book. It's generally if you've got something like a Yahoo Mail where you can switch out the entire theme. You can change all the colors to green or whatever you want them to be. Those are themes. So you don't have to worry too much about that. But if you do have a theme, they can apply to all of the other types. So SMACSS has a few goals. We want to increase semantic value through naming. He is a big advocate of semantic classes. He aims to separate container and content via these different categorizations and via classes. And lastly, he aims to reduce the depth of applicability via child classes. So what does depth of applicability mean? And that essentially means the number of generations that are affected by a given CSS role. So the greater the depth, the greater your coupling to your HTML. So we've got some examples down here. The first one, body.article, descendant selector main, descendant content, descendant intro, P, B. If you count all those up, we've got 6 separate selectors. So that's a depth of 6. Now, if we were to try and make this better by just eliminating some of these middle selectors, if we try to pull out main and content and paragraph, we're still at 6, because that's still the number of elements that are actually in the HTML that we have to go through to style these Bs the way that we want them to be. So Snook describes SMACSS as like a flexible guide to developing sites. So if you read the book, sometimes his depth and his nested element selectors are okay. Just like you saw before, we had an anchor nested under our nav item. Sometimes that's okay. Sometimes you should use child classes. But he's got one quote that I think sort of sums up this balancing act of modular CSS that we're working with. And he says, we're trying to strike a balance between maintenance, performance, and readability. Going too deep with selectors may mean less class situs within your HTML, but it increases the maintenance and readability overhead. Likewise, you don't want or need to put classes on everything, just like we saw with like that Arbor OOCSS example where we had tons and tons of classes. So those are the core concepts of SMACSS. We've got base, layout, module, state, and theme, focus on semantics, flexibility, and organization. Now really quick to go over sort of an alternate system, we have atomic design. Very similar to SMACSS. It's an entire methodology for constructing design systems. Designed by Brad Frost from Pattern Lab. And atomic design is all about assembling smaller pieces into a whole. So again, where OOCSS only really has one type of object and SMACSS has 5 types, atomic design also breaks its components into 5 pieces. Atoms, molecules, organisms, templates, and pages. As you can see, it takes a very organic approach to its naming. And we're going to focus on the first 3 since the latter 2 are a bit too abstract for today. But let's identify these. So atoms are the basic building blocks of matter. They're pretty much the same as the base styles of SMACSS. These are going to be your element selectors. They're going to be your global styles, your defaults, your CSS resets. We want all things to look like this. Your molecules are groups of atoms bonded together. He's going very, very scientific with this. Like, that's the definition of a molecule in science. But these are similar to SMACSS modules, except a little bit smaller and a little bit simpler. They're combinations built for reuse, and one of the things he says is building up from atoms to molecules encourages a do one thing and do it well mentality and encourages creating reusable interface patterns. So things that would fit in this molecule type are things like search forms, where you've got a label, an input, and a button. Like, it's just 3 elements, but you're tying them together to form this tiny little search thing. a flash message that maybe has a header and a body, a button, a tab, a thumbnail. Very small things. Organisms, the next step up, then groups these molecules together to form bigger, complex sections of an interface. Things like headers, footers, sidebars, etc. Now, atomic design is not just a methodology for writing CSS. It's actually part of an entire design system called Pattern Lab, which is kind of a collection of tools that do all of the things. At its core, it's a static site generator that you kind of use to build out your atomic components. So it comes with a kind of style guide component library piece, all sorts of like browser tools. It's a pretty interesting thing. It's worth having a look if you're interested in this organic approach. It is open source. You can run it locally. All right, so we've looked at a few of the most popular methodologies. So how do we actually get started? How do we start refactoring our code or creating new systems with these concepts in mind? And I like to say that architecting a modular system is pretty hard to do. You've really got to just continually organize, optimize, and repeat the process over and over and over again until you find that right level of granularity. So it's basically about iterating on abstraction, continually isolating code and refactoring until we find that right level of granularity. Do we use tiny presentational objects, or do we use larger semantic ones? So to do this, we first need to sort of establish those conventions. You know, pick a naming system, pick a categorization system, decide on some code formatting standards, and then document everything. Seriously. Create a style guide. Build your objects in the style guide before you even put them on the page. Relying on a style guide for this is going to help confirm that encapsulation. It's going to ensure to you that no matter where else I put this component, it's always going to look like this. And it's also a really great testing ground. If you're concerned that some style might break somewhere, you've got that style guide that's got all of your different modules. You can flip through that and verify that everything is good. Utilize a CSS preprocessor. If you're not already, get on that. They go hand in hand with modularization. You can split your objects between separate file partials. You can use actual nesting. You get things like variables, mixing, all sorts of tools to help dry up some of the repetition that we're still going to get with approaches like OOCSS and SMACSS. So preprocessors, basically the best things to happen since sliced spread. I'm a big fan of SASS. You might have already heard that. And lastly, of course, as we said before, we want to stop using CSS selectors for non-CSS. That's going to fix like half of this problem. So the good news is that once you switch to this modular architecture, it won't even make sense to use your CSS classes for JavaScript or for feature spec hooks anymore, especially if you go the presentational route. Like you're not going to probably hook up some JavaScript to a no margin class. It just doesn't make sense. So lastly, finally, just remember that no one knows what they're doing. So experiment. There's a lot of options, a lot of ideas and opinions. There's a lot of reading you can do around this. So I would say play around with stuff and figure out what works best for you. And that's it. Thank you. Do we have time for questions? Anyone? Questions? Okay.
So, well, you were talking about using a precompiler like SASS. So I've always seen one of the big strengths of SASS was the nesting of classes, and it seems like you probably avoid doing that pretty much entirely.
Yeah, there are some people who would pair a modular system with a preprocessor would completely just not use nesting. I would say it's still fine for things like pseudo classes, your hover states, your before and after styles. Like those are perfect. If you're going with SMACSS, you know, maybe you're going to nest a single element here or there if you can count on it to be there. So definitely, like some nesting's fine, and it's going to happen depending what the object is. I wouldn't avoid it like altogether, unless you want to.
I was just kind of
That's true.
So
Yeah.
your names are all like button dash dash something.
Yeah, especially with like the BEM naming system and SASS, they have this parent selector where if you were to nest within SASS, you would use this parent identifier and it would grab whatever the class that it's nested in. If you're using BEM, you could nest parent selectors and just append dash dash modifier or underscore underscore modifier to that parent selector, and they wouldn't actually be nested in the output CSS, but you wouldn't have to repeat that top level object all over the place. So there's things you can do like that.
Is there functionality in SASS that you would, that is not in like less, possibly to say, to say, use SASS?
No, they're pretty similar. All the functionality is there. I will say I just went to CSS DevConf a few weeks ago, which had a lot of the big names, and I was fortunate to be able to ask a question to a panel of all the speakers, and I asked them, who here uses a preprocessor? Which one do you use? Why did you choose it? Or why are you not using a preprocessor at all? And of like the 15 people up there, only 2 or 3 were not using SASS. And they were using, I think one was using Stylus, the other was using Less, maybe another was using Stylus. But they all are very, very similar. They all do the same things. I think a lot of the reason people are using SASS now or moving to SASS is purely the community. There's a really, really strong community, very similar to this JavaScript community. We all get together, we all help each other out. With SASS, it's very much the same. So there's a lot of things happening in the technology. A lot of people are contributing to it, so it's growing very quickly. And it's just a really strong community. So, let's do that. Anyone else? Cool. Thank you. I will also put these slides online, and if you do want to read a lot more about this one guy, David Clark, put together a whole list of resources on scalable CSS and modular CSS. So I would just go to that one link and just start clicking through stuff.